Okay, hello. I'm just going to do a quick walkthrough of the when should I get to the airport. To make this as efficient and as speedy as possible, I've done a tiny bit of the preparation work, just setting up my spreadsheet, just so we're not wasting any time during that, because who needs to waste time? I know that other people will have done walkthroughs. I think Eric's already done one with a kind of speed solve, doing it in about 15 minutes, which I'm not going to try and compete with that, because I'd like to take my time to just explain a few things, which is more for me than for anything. Just as I've said in other walkthroughs, I just find the process of doing this very helpful for my own learning more than anything. And if it helps anyone else, great, but that's not really the reason I'm doing it. So I will time myself just so that we know how long it took, but not for any kind of competitive point of view, and just to allow me time to explain the questions as we go along. So I'll also explain where I went wrong when I did it the live time, because I've worked out what my mistake was. So let's start the clock and let's get going. So I'm going to start by setting up my data. So we've got everything in the table. In the actual live thing, I did this as a table, but now I think I'll just do it as named references. So I'm just going to rename some of these to remove spaces, just because that's annoying when you are doing references inside a function. So just making something a bit tidier, call that just departure, arrival, registration, because they're the same aircraft. We'll call this seats, and we'll call this tickets. And I'll select all of that, Control Shift F3 to name all of those ranges. Okay, that's all I need to do for now. And then levels 1 to 3, we're going to do single cell, and then level 4 to 7 we'll do as a data table, which I've already sort of set up. So level 1, how many flights from each city? So we're just going to go count ifs the from city matches these cities. We can do that all in one go, and that's good. Level 2, how many flights from the listed airport that fly into Las Vegas? So slightly more complicated. So count ifs the from code is these cities, and the to code is LAS for Las Vegas. And that's all of level 2. And then level 3, how many flights leaving from the listed airport between these times? So another count ifs. So we're going to say from code, not from city, from code is this, and then our departure time is greater than or equal to time 500, and then departure is less than or equal to time 7000, and we'll just fill that down, and that gives us all. So those are the first 3 all done single cell. So now we're going to go on to level 4. I've set these up as data tables already, just to make this nice and efficient. So how many other people are taking flights from the same airline at the same airport within a half hour of yours? So we need to find out that information. So for airline, we're going to XLOOKUP B1 in our flight number, returning the airline. And then we're going to do the same thing here, XLOOKUP B1 in our flight number, returning the airport. No, so the airport, we're going to go from code, and we're going to use the code, not the city, because some of the cities have multiple airports. And then we need to find the time that we're departing. So again, looking up flight number in the departure time, and we want to find what's the time 30 minutes after that. So we'll do that plus time 0:30, and we'll do the same for the other one. So time minus time 0:30, and those are our 30 minutes plus. And so we want to know what are the number of tickets sold. So we're going to filter the tickets where, let's think about this. So from the same airline, so where airline equals United Airlines, and the airport, so that's the from code equals airport, and departure is less than or equal to 6:35, and the departure is greater than or equal to 5:35, and close that off. These are all our tickets. We'll sum that, and then on this one we are sum is 1922, but because we don't want to include ourselves, we're going to minus 1 from that, and we'll point that to our data table, and we'll just go back to the case to make sure that's correct. Yep, level 4 all correct. We'll go to level 5. So I'm going to copy my workings from level 4 over to level 5. So starting point is the same. So we've got our 1921 passengers, but when they arrive, only 35 are checking in, and of those already in line. So we're going to take this number. It is the 1921, so without us, so we'll multiply that by 0.35 and then by 0.25, and then we're going to divide that number by the number of check-in counters, which gives us 24. And for our final answer, we're going to round that. And this is the thing that got me in trouble in the real thing, because I did the rounding over here, and then when I copied my working over to level 7, I didn't remove that rounding, which is why I got that wrong. Or only got half of them right on the last level. So that's level 5 all done. Level 6, again, I've kind of got the question over here. So actually here, we're going to work through the example. So again, I'm going to grab my workings from level 5. Let's do the level 5 workings, and we'll adapt it. Okay, but we're no longer interested in the tickets. Firstly, we're looking at all flights from Newark, so we're no longer need the airline condition. So there are more flights. We are now including ourselves, so we'll take out the -1. So there are 3,716 tickets sold, but some of those are overbooked. So we now need to deal with the fact that some of them are overbooked. So we're going to have a column here for seats. And we're going to grab this formula and just copy it in here. But we're going to change tickets to seats. And then when we basically need to get rid of anywhere more tickets were sold than seats available. So this first one, they sold 169, but they're only 162. So for this, I used a map lambda. So I'm going to map through the tickets and the seats, and my lambda is going to have T for tickets, don't like the capital there, T for tickets, S for seats, and all I want to take is the minimum of those two, because if they sold more than they have, then that's what we need. So we now get 162 is the minimum of those two. So that's actually how many possible passengers there are, and when we point our sum at that range, we get the 3,670. And actually they do want us to keep the -1 here, so they only want us to use 3,669, and we estimate 25% are in line, but only 15% went to fast pass, so we're going to change that 0.35 to 0.85. So we've got 779, and this is already looking at the 10. So again, for my final answer, I'm going to round that number to 0 places. And when I go to the case, level 6 is all correct. And then for level 7, what I'm going to do is we need to use our workings from level 5 and level 6. So we'll start with level 5. And we'll paste that here, so 24, which is what we should expect, and then we'll grab our level 6 workings, but we'll put them over here, and so some of the references won't be correct, so we'll just move these over to the relevant slots and do the same for the seats as well, moving that across here so it's looking up the same stuff. So, and then this is trying to divide by that number, so it needs to divide by 10. So now we've got our thing, so we can say how many people at check-in. Let's put this in bold. So check-in is equal to that number. It's formatted as time because I formatted that whole column. So then security equals this number, but at check-in, each person takes 2 minutes. But at security, they each take half a minute. So the total minutes is these two numbers. So 48 plus 38 plus the 3 minutes of walking plus the 30 minutes of getting to the gate, which gives us 194. Something's gone wrong there. Should be 120. So got 78 people there, 24 there. That should take 39 minutes to be screened. What have I done wrong? 24 people in lines, 48 minutes, 30 minus. I put a times instead of a plus. Plus, there we go. So we get 120.1. And what caught me out in the real thing is that's so close to 120 that in the example where they said 12.1, I didn't have that because I had rounded here because I still had my rounding from the original work. So I'd rounded both of those, which is going to set me up with a problem later because our total time, we're going to round down the number of minutes. And then what we're going to do, so that's the total number of minutes. And then the time we need to leave is going to be our flight departure time minus, I'll put this in brackets just to be able to say this divided by 60 divided by 24. And that gives us what looks like a number, and then I'm going to format that as text, which is what I did on the live case. So we want to format this in the form hours, minutes, AM / PM, and that gives us our 4:05, and we point to that and we get our answers, and we'll just go back to the case to check we've got them all right. Yes, so we're all correct on all of the main levels. So let's go to the bonuses. Which airline has the most flights on the flight data sheet? So I did this using, so I'll import my lambdas here. So I use the most least on airline, and then if I put an at in front of that, it returns the first answer. How many unique airports are listed in the flight dates? So what I'm going to do is I'm going to use a count all of the unique values from a VStack of the from code and the to code, and close that off, and we get 350. Only one airport has just a single flight arriving to it and no flights departing all day. So what I'm going to do here is I'm going to do a group by, actually I'm going to use most least on my to code, but I want the least. So here are my ones that only had one flight. So I'm just going to copy those as value. Didn't mean to do that. Something went wrong there. Let's undo. Oh, something gone very wrong there. Let's try again. So let's do most least of to code 1, and then I'm just going to copy all these ones that only had 1 as values only, and then I want to count ifs the from code matches those, and we've got a 0 there. So let's X look up this in the to code and return the to city, and we get Jonestown, PA, or Johnstown, PA. Which airline has the lowest average flight number? Ignoring the letters, so I'm going to go over to add an extra column. We'll call this numeric, and what we want to do is extract the numbers from the flight number, fill that all the way down, which takes a long time because there's 18,000 or 22,000 rows. Oh, and what I might do, it's struggling with that because look, those are all the same, which is not correct. I'll tell you what. Oh, now that seems to have done it. What I might do is copy those as values only, just so it's not doing that recalculation each time, and then I'm going to name those numeric. And then what I want to do is I'm going to do a group by, so I want to group on the airline as my, and I want to take the numeric values and I want to average them, and we'll sort them in ascending order. And I've done something wrong here. Let's get rid of my, so that's because my numeric range refers to the title as well. So let's go to the name manager, go on numeric and change that start in row 3. And then we go, and so that, let's do this in, and we see that Hawaiian Airlines has the lowest. So place that in there. Sometimes airlines like to reuse flight numbers. How many flight numbers are used more than once? So let's go over here. Let's go unique flight number. And then let's copy and paste that just because make it easier. And then we're going to count ifs flight number equals that. And yes, this is having a bit of an issue with, notice this before. I think Eric had something very similar where suddenly these kind of large calculations on this range seem to cause an issue. So what I'll do is try that, fill that down, and then I'm going to filter this range where that range is greater than 1, and then I'm just going to count the number of rows in that range, which is 3698, And there we go, all correct. So let's check our time. I thought I was going to be slower than 15, but there we go, 30 minutes 44. Obviously, I did do some of the pre-work. So basically, all I did beforehand was I created a data table. I've got a little macro that does this for each level. So reality, that'd only take 5 seconds or so. And then I think I'd pre-populated on the first of these headers just to direct me where to go, and then I copied the screenshots just in case I needed to refer to them. So which is why those game hints don't look correct when they're doing it. So yeah, interesting case. As I said, the mistake I made in the real thing was on level 5 and 6 you're asked to round this answer here, so in this case the 24.01, which gives us 24, and I did pretty much the same thing where I copied my workings from level 5 and level 6, but in the real thing I added my round in here. And so let's see if I can recreate the exact error I made. So if I put round in there, actually no, let's not put it there, let's put it in level 7. So I'm going to copy these answers as values. So if I put round in here, do the same over here. So I'm rounding kind of intermediate workings, which you're never meant to do. Let's see, we can see, yep, some of those are different. So there's a minute difference. In fact, if I go back to the case, actually I still got we can now see those exactly the ones I got wrong in the real thing. So yeah, very frustrating, avoidable error, which I should have been wary of because the question mentions it does tell you not to do it. So it says somewhere here, where is it? You do not round any other calculations at any point. So that was my issue. So yeah, anyway, I enjoyed that case, fun case, nice to kind of build up workings from previous levels in a nice, neat, tidy way. So yeah, very good fun. Always learning something new. That mistake about rounding, that's the first time I've done that in a live case. So that's not a mistake I'll hopefully ever make again. So thanks for watching.